I will do this exact same problem that's showing up right now. A couple of things about the layout. I wrote my directions right here. The problem starts here, 5, 20, 25, 30, 40, 50, 60, and so on. I left some space at the top when I worked this problem so that after I worked it, all this stuff that I've written in red is the interpretation of the answer. So when I write this on a blank piece of paper, I'm going to leave that gap. I'm telling you this so you can leave that gap in your notes so that you know when I come back I want to write a few things there. This is a 6-step process. Step 1 is that we find the mean. Step 2, every score in the data set, I have to subtract the mean from it. Step number 3 is I'll take the numbers from step 2 and square it. Step number 4 is that I add the numbers from step 3. I wrote something in red here. That's the sum of squares. If you take a statistics class, they're going to give that sum a name. It's called the sum of squares. Step 5, I divide the sum of squares by 1 less than the number of data items. This problem had 11 items, so I divide by 10. And then step number 6 is that I take the square root of the number that I got in step 5. The number I got in step 5, in a statistics class, they will call it the variance. And again, step 6 is to do the square root. That number is the standard deviation. I'm going to work this exact problem for you, and I'm going to write it all out. I will call this example number 1. Find the standard deviation. I want to point something else out about this data set. This is a data set that's just perfectly symmetrical. I made up this data, and I wanted this first problem to be a problem where the middle number is 50. From 50, I'm going to build my data set out towards each side with, let me go 10 higher than 50 with 60. And let me go 10 lower than 50 with 40. And then I have my next data item that is 10 higher than 60, 70. The next one is 10 lower than 40, so it's 30. Then I don't have to keep going by 10. I went up by 5, 75. I go down by 5, 25. And then I went up by 5 again to 80. Down by 5 again to 20, and then I went up by 15 to 95, and down by 15 I get 5. So I wanted a data set that's perfectly symmetrical like that. In the real world, your data sets are not going to be perfectly symmetrical, but in this case we have one that is. Step number 1 on the standard deviation is to find the mean. The standard deviation is a measure, it's an average of how far the scores are from the mean. So I'm going to have to find the mean. Now, because this data set is perfectly balanced, perfectly symmetrical, the mean is going to be 50. If you're not sure about that, you can calculate it. And if you are thinking, what do you mean by the mean is 50? You can tell that just by looking at it. As I look at 5 and 95. 5 plus 95 is 100. 100 divided by 2 is 50. 20 plus 80 is 100. 100 divided by 2 is 50. As I add the scores together from each end, I'm going to always get 100. That's 2 scores together, and then you got the 50 in the middle. But at any rate, no matter how you find it, the mean is 50. Remember, I think I mentioned it last time, we write the mean as x with a line on top. I can read that x bar, and in this problem, x bar equals 50. And if you're not sure about that, you can go ahead and do the calculation, and you'll see that it's 50. Step number 2, I'm going to put step 2 in a column on the left side of the page. Step 2 is I take each score and subtract the mean from it. I will write for step 2, score minus mean. This will be in a little column right there. My first score was 5. So this will be 5 minus 50 is negative 45. The next one was 20. 20 minus 50 is negative 30. The next one is 25. 25 minus 50 is negative 25. And then 30 minus 50 is negative 20. 40 minus 50 is negative 10. And then 50 minus 50 is 0. I need to now continue, and I get to where now my subtraction is going to be positive numbers. 60 minus 50 is 10. 70 minus 50 is 20. 75 minus 50 is 25. 80 minus 50 is 30. And 95 minus 50 is 45. Now what I'm about to say next is not a part of the calculation for standard deviation, but it is something that you will be asked some questions about. If you add these numbers I've gotten from my subtraction, what are you going to get? You're going to get 0. They're perfectly balanced. And if you look at this, negative 45 plus 45 is 0. Negative 30 plus 30 is 0. Negative 25 plus 25 is 0. Negative 20 plus 20 is 0. Negative 10 plus 10 is 0. And if you add them all together, they will sum to 0. Now this is a way you can kind of check your work up to this point. I had a student a while back, a few years ago, she wrote me an email and she said, I'm doing something wrong. I don't know what, but I know I'm doing something wrong because my sum is not 0. And I looked at the problem she was working out, and she had it all right. But what the problem was, that particular problem, there were a lot of decimals. The mean had a decimal that just didn't end, so she rounded off, as she should have at that point. So her sum was close to 0. It was like 0.015 or something like that. And I said, oh no, you're fine because you have round off error in that problem. It is correct. Now some of the problems on the computer, they're having you do some of these intermediate steps, and one of them is to do the subtraction and then to say the sum of those numbers is 0. For step 3 in my calculation, we're going to take the numbers from step 2 and square them. Score minus mean and square it. The first one would be -45 squared. I'll make a little comment about this. I'm going to go to a new sheet of paper for this. You have to be careful somewhat on your calculator for this, because if I type in -45 in parentheses squared, well, that's -45 times -45. And a negative times a negative is going to be what kind of a number? A positive. In my calculator, parentheses, -45, close parentheses, hit the x squared key, and I get positive. Now, if you do the problem like this, -45 squared, you are not going to get a positive number. I'll show you that on the calculator. -45, no parentheses squared, is -2025. And for what I typed in, that is correct, but I didn't type in the correct thing. I will confess to you, this is a little fact I didn't know until I was enrolled in grad school going for my master's in math. I already had a bachelor's in math. And I remember this algebra class and that I was observing a teacher in, and I'm like, wait, that's not right. But yes, it is right. If I don't have parentheses, it's really -45, like it's really, I could really put the parentheses around the 45 times 45. Or I could think of it like this. -45, no parentheses squared, is really -1 times 45 squared. That negative does not act, or the square does not act on the negative sign. Why am I kind of stressing all this? Because if you're typing this in your calculator, you have to know all of these numbers are going to end up positive. I have to square the negative sign, 2025 for that one. -30 squared. You know what you could do? You know it's going to be positive. -30 squared, that's the same as 30 times 30, 900. Your choice on how you want to type it in. But you have to know that they're going to be positive. I've seen students make mistakes where they kept the negative in there, and that was their only mistake in the problem. You know, and they might not do it for all the numbers, but they might say, make that mistake right here, -400. And that's going to throw off their entire calculation. So let me erase that because it's not that, it's +400. Then the next one's -10 squared. The negative is squared, that's 100. 0 squared is 0. 10 squared is 100. I'll do another column. 20 squared is 400. 25 squared is is 625. And then 30 squared, we're right here, 900. And then 45 squared is 2025. So add those up. Go ahead and square all those numbers. The fourth step is that you're going to add the numbers from step 3. Step 4, add the numbers from step 3. So I'll just do an addition on my calculator. 2025 plus 900 plus 625 plus 400 plus 100 plus 0 plus 100 plus 400 plus 625 plus 900 plus 2025. I added them up and I got 8,100. Step 5 is the one that students, sometimes they'll raise their hand after we've done with the calculation and they'll say, I understood everything you did, I got it, but why? Why are you dividing by one less than the number of numbers? Let me write it out. Divide the sum from step 4 by one less than the number of scores. So I'm going to do 8,100 divided by 10 because there were 11 scores. I get 810. We divide by one less than the number of scores because it is an adjustment factor. I'll try to explain it maybe after we work the problem, but it's an adjustment factor. A few years ago, I wasn't sure the answer to this question, so I phoned a friend. I phoned a friend of mine. She lives in Minneapolis. I met her when she was a grad student here. She got a master's in math, and then that wasn't enough. She got a master's in statistics. So I called her up and she told me it's an adjustment factor. It's an adjustment for things like some rounding that might have occurred. And that's a good answer. It's not, you know, what kind of rounding or what kind of adjustment, but an adjustment. Let's just call it that for now. Step 6 is we do the square root. And this is now the square root of 810. This is now the standard deviation. On my calculator, I'll go second x squared to get the square root button. It's going to open parentheses for you. It is a good idea for you to get in the habit of closing the parentheses at the proper place. This is square root's 28.46. There's a lot of digits there. I'll go with 28.46.